This question is a curve sketching question. So first off, let us consider the question here. The concentration of a drug in a patient's bloodstream at H hours, so this is a time variable here, H, after it was injected is given by this formula here. A is a function of H, so that's the concentration level. Okay, and it changes over time, where time here is denominated in terms of hours. So the concentration level at time H is given as 0.17 H over H squared plus 2. Just a sort of quick example of that, just to sort of flesh it out. Suppose we want the concentration after 1 hour. That would be 0.17 times 1 over 1 squared plus 2. That would be 0.17 over 3, and that would be, essentially just divide that by 3 and you get 0.0566, something like that. That's just the sort of general gist of it. Now, so that's the concentration after 1 hour. Now, what we want to find here is we're going to set up a curve sketching question here. So what we have to do here, there's two parts of this. Find the intercept of AH, the intercept, so the axis intercepts when we graph it. So because we're sketching a curve and we need to know where the intercepts are. And also determine the behavior of AH as H approaches plus infinity. This second part here is related to the asymptotes. Okay? And there's a sort of an implicit clue there about one of the asymptotes. I won't give the game away. We'll actually do it out. So what we're looking here is for the vertical asymptote and the horizontal asymptote. Okay. So we have to find the intercepts of AH, and then the behavior of the asymptotes essentially. Now, so let's go down here. Just as a sort of quick remark. We're just going to slightly rename our functions here. So we're dealing in terms of A and H, which is concentration level. Okay, but also what we're interested in, we're just going to sort of translate back to H's hours, but we're just going to sort of translate back to Y and X for just sort of sake of simplicity. The concentration level is a sort of response to the number of hours, so it's a function of hours. So it's going to be the Y variable, okay, and X is going to be the hours variable. So we're going to sort of set up our plot like that, okay. Just a sort of quick remark there again. There it is, our graph again, or that's our yeah. So essentially, just to sort of highlight that A is a function of H, so that's why A is the Y variable and H is the X variable, essentially. Okay, so let's go down to this next part here. So, Y-intercept. Now, again, Y-intercept is the general procedure for finding a Y-intercept is just let X equal to, that's a sort of bullet point there. It's not a minus sign. Let X equal to 0. So here what we have to do is find A of H when H is equal to 0. So let's do that. So this is our Y-intercept. Okay. So A when H is 0, so A of 0 is equal to 0.17 times 0 over 0 squared plus 2. That's 0 over 2, and that is equal to 0. So the Y-intercept is also 0, 0, 0. That's interesting actually, because that might sort of give us a clue as to the next one. If at y equals 0, sorry, I'm just going to sort of scroll back up there for a second. At y equals 0, x is equal to 0. So actually, just a remark, it goes through the origin. X equals 0, y is equal to 0. Okay, that's just something to pick up on there, that it goes through the origin. X equals 0, y equals 0. That gives us a clue as to how this next one is going to turn out already. X-intercept let y is equal to 0. Let y equal to 0. Okay, so that's the general procedure here. And again, translating it in terms of A and H, what we have to do here is find H when A of H is equal to 0. Okay. Now, essentially what you should be looking out for essentially is that if x is equal to 0, then y is equal to 0. Maybe when y is equal to 0, x is equal to 0. Just as something to keep an eye out on. We know it goes through the origin now. So maybe there might be somewhere else, but maybe there is a very simple answer here. So, not let all of this equal to 0, not 17h over h squared plus 2 is equal to 0. How do you solve this? Well, essentially what you have here is a numerator and a denominator, a over b equals 0. And necessary to avoid a divide by 0 problem, essentially what we're going to sort of conclude is that the numerator a is equal to 0. Okay? So 0.17h is equal to 0, necessarily h is equal to 0. That sort of corroborates, that's the numerator, by the way, this part here. And this is the denominator. So in this is sort of avoids the divide by 0 problem. If we have a fraction a divided by b, and that's equal to 0, necessarily you conclude that a is equal to 0 because you can't divide by 0. B can't be 0. So 0.17h equals 0. Therefore, just to sort of reworking that, h is equal to 0. So again, that concludes corroborates what we found the last time round, that it goes through the origin. Okay, and also that there's no other solutions. There may potentially be the case that there are other points where there would be an intercept. Okay, so but not in this case. Asymptotes. Now, I'll just sort of go back to the way the question was phrased because they may not necessarily exist. Okay, so I'll just go back to the way the question is actually precisely phrased. Determine the behavior of a of h as h approaches plus infinity. So that gives a sort of clue as this is the horizontal asymptote, but it doesn't really say that much about the vertical asymptote. Okay, so it doesn't really ask anything about the vertical asymptote. And the thing you've got to keep in mind here, is just scroll back down here, is that asymptotes may not necessarily exist. Okay, there may not necessarily be a vertical asymptote. There may not necessarily be a horizontal asymptote. In some curves and some functions, you will have them. You'll have one of each. But in some, you might have a vertical asymptote only, and some you might have a horizontal asymptote only, and in some functions it might not be either. You might have neither a vertical or a horizontal asymptote. So, where am I? So, asymptotes may not necessarily exist, but let's just sort of have do it from first principles anyway. So, this is our expression here. What we're going to do here is look for the vertical asymptote, and this is our expression here. A of h equals 0.17h over h squared plus 2. And the procedure for finding vertical asymptotes is to let the denominator of expression, which is this bit, equal to 0. Okay, so what we're going to do is that h squared plus 2 is equal to 0. Okay, h squared is necessarily equal to minus 2, and h is therefore necessarily equal to the square root of 2. For what, I mean, that actually does exist. That's what they call a complex number. Okay. But as far as we are concerned, that indicates vertical asymptote doesn't exist. That's our conclusion there. It's a complex number answer. It's essentially not. It doesn't give us a nice, neat number. It's not on the plane. We have a and we have a sort of very simple plane, a and h or x, and but that is complex numbers don't exist in that. So essentially, with no viable solution, it's a complex number. Vertical asymptote doesn't exist. So that sort of was indicated by the question earlier on. Now, horizontal asymptote. I mean, we were sort of given a steer about this in the question that this would exist. This is the general form of it there. But what we're going to do is slightly translate it into how this question is set up. What we're looking for is the limit as h approaches infinity of a of h. So let's do that. There we go. Limit as h approaches infinity of 0.17h over h squared plus 2. Let's do that out. That is, I'll just tidy that up there a bit first. 0.17 times infinity over infinity squared plus 2. That's infinity over infinity, indeterminate answer. Indeterminate. So what we got to do is just try it out again. So limit as h approaches infinity of 0.17 h over h squared plus 2. Divide by the highest power. So we're going to divide everything, the numerator and denominator, by h squared. This is the highest power here, h squared. So let's do that. Limit as h approaches infinity of 0.17 over h times h squared over h squared. Sorry, I'll just keep this consistent. I know. I'll just do here 1 plus 2 over h squared. Essentially, 0.17 h squared is divide h above and below, and you get 0.17 over h. H squared divided by h squared gives us 1, and 2 divided by h squared gives us that last term. Okay, so just divide everything down by h squared. When we put in infinity here, now we evaluate it, we would get, just scroll down there a bit more, 0.17 over infinity over 1 plus 2 over infinity squared. 0.17 divided by infinity, anything that divides it by infinity is treated as 0, and also infinity squared is treated as 0. Infinity squared doesn't really make sense, it's infinity really. So essentially what we have here is 0 over 0 plus, 1 plus 0, and that's equal to 0. So the limit, the asymptote, horizontal asymptote, is 0. Okay. It makes sense in a way, because after a while the blood, if there's less and less concentration of blood of this drug in your system, after a while it has to sort of go out of your system. Okay, that's enough of that. That's curve sketching, asymptotes, and intercepts.